So today we're looking at computation with integers. It is all revision. There is nothing new. This should be a nice, easy lesson for you. First thing we're going to look at is positive and negative integers. Now, integers are whole numbers. They could be negative, positive, or zero. We're just going to quickly remind ourselves what are the rules when we start doing operations with positives and negatives. So, for example, if I had negative 3, let's calibrate that, times a negative 2, what is the rule for a negative times a negative? Positive. It will give me a positive answer, that's correct. Okay, hang on, let me just change that. Negative 3 times a negative 2 would give me a positive 6. Do I need to write the positive? No. If it's a positive number, we don't write it. Alright, so if you are multiplying or dividing two negatives, it gives a positive answer. What if I have a positive and a negative?
You get a negative answer.
Get a negative answer. So if I had negative 20, I divide it by 4, what's the answer?
Negative 5.
Negative 5. Excellent. So if the way I remember it is that the signs are same, gives you a positive answer. Signs are different, it gives you a negative answer. Okay, that is for multiplication and division. Your standard plussing and minusing, you need to think of the number line, where you start and where you're going. So if I had negative 4 plus 12, that means I'm starting at negative 4 on my number line. I'm moving up by 12, so where do I end up? At 8. What happens if they try and trick me and put a double negative in? So they might have 8 minus negative 3. If I minus a negative, what am I doing? Adding. So minusing a negative is the same as adding. So that actually means 8 adding 3, which gives me 11. You guys have lost your voices over the holidays. Okay, so does everyone remember the basic rules for positive and negative? Alright, the reason I'm going over this, I know this seems really basic, but the number of silly mistakes I see with negatives is a bit sad. Alright, I don't want to be seeing little tiny mistakes with our signs. When we get to doing more complex things, make sure you keep these ideas in your head. Okay, next thing, squares and cubes. Let's move that down. So squared obviously means, so if I have 3 squared, what does that mean?
It's timesing it against itself.
Timesing itself. So 3 squared means 3 times 3, which is 9. What if I had negative 2 squared? What does that mean?
Negative 2 times negative 2.
Negative 2 times negative 2, so what's the answer?
4.
4. Watch out for that one. That's probably one of the most common silly mistakes, is when you're squaring a negative, you give me a negative answer. Because if you type in negative 2 squared on your calculator, it tells you the answer is negative 4. Okay? It gives you the wrong answer unless you put it in brackets. So that's probably one of the most common negative errors that I see. If you put in, I don't know, probably wouldn't put negative 2 in the calculator, I guess you'd know that, but maybe you had, I don't know, negative 53 squared. I don't expect you to know negative 53 squared without a calculator. So you grab your calculator, you type negative 53 squared, and it gives you a negative answer, unless you put the negative number in brackets. Okay, so watch out for negatives, okay? You need to use brackets on the calculator. Or your brain. Okay, so be very careful for that. Okay, what about cubes? If I had 2 cubed, what's that?
8.
It's 8. 2 times 2 times 2, which is 8. What's negative 2 cubed?
8.
Is it 8? Is it negative 8? Which one?
It's negative 8.
It's negative 8, because we have negative 2 times negative 2 times negative 2. This bit here gives me a positive 4. Then I've got 4 times negative 2. It's going to give me negative 8. So basically what you'll find, if you're putting a number to an even power, it's always going to work out to be a positive answer because all the negatives will pair up. But if you're putting it to an odd power, if it's a negative number, you're going to get a negative answer because you've got that one left that doesn't have a pair. Okay, squares and cubes, apart from that, if they're big numbers, you reach for your calculator. Just watch out for those negatives. LCM, HCF, what are those?
Lowest common multiple and highest common factor.
Okay, lowest common multiple. And highest common factor. Okay, these two get confused sometimes, so be careful. Lowest common multiple. Okay, so if I just pick two numbers, let's say I've got 8 and 6. I need to find the lowest common multiple of 8 and 6. What does that mean? What is a multiple?
So something, if you were to times 6 by something, that would be a multiple, right?
Yes, so multiples are basically the answers from multiplication. So the multiples of 6 would be your answers from your 6 times tables. So it would be 6, 12, 18, etc. And the multiples of 8 would be your answers from your 8 times tables. So it would be 8, 16. So let's write a few of them down. So we do 6, what have we got? So 6, 12, 18, 8, 16. We got anything common yet? Have we done the first 3?
Oh, well, you're about to have.
I'm about to have the common one, aren't I? I need one more over here. And there's my common multiple. So your multiple will always be at least as big as the biggest number. Alright? So for example, if my two numbers were 6 and 12, that's okay. You can have one of the numbers as your lowest common multiple. 12 could be the answer. Okay? So this one obviously 24. So your lowest common multiple must be at least as big as the biggest number, if not bigger. Highest common factor. What are factors?
Numbers that times together make the number that you're...
Yeah, so it's kind of like the questions from our times tables, isn't it? Okay, it's what operation you do to get those answers. So the highest common factor of, for example, 12 and 15. So instead of looking at what are the answers from your times tables, you want to look at what were the questions. So I need to know all the questions that gave me an answer of 12. So that would be 1 times 12, 2 times 6, 3 times 4. They are all the questions that would give me 12 as an answer. What are all the questions that would give me 15 as an answer? 1 times 15. 3 times 5. And that's it. There is no more. The way you know there's no more, there's a nice little check. What I do is I start with 1, and then I keep checking every integer. 2 doesn't work. 3 does, it's 3 times 5. 4 doesn't work. 5 I already have. You keep going until you find a number you already have, and then you know you didn't miss any. That's kind of cool. Okay, you can guarantee you'll get every factor if you do it that way. So looking at those, which is the highest number that is in both? 3. So for this one, 3 is the highest number that's in both. Now I don't expect you to write those things down each time. For these very common numbers, I expect you to look at 12 and 15 and you can tell me, answer's 3, highest common factor. Okay, you've got to get fast at these. This is just a reminder of the process that you should be doing in your head. This does not go on your paper normally. Okay, that happens in your head really quickly. Alright, what else do we need to know about integers? What's a prime and what's a composite? What's a definition? A good definition of a prime? Prime numbers. What's special about a prime number?
Its only factors are itself and 1.
Its only factors are itself and 1. Well done. The only factors are itself and 1. So is 1 a prime number? No. 1 is not a prime number because its only factor is 1. It doesn't have 2 factors, so it's not a prime number. What's a composite number? Interestingly, they just found a new prime number. Very exciting. It's got like millions of decimals, millions and millions of numbers in it. And it just was in the news quite recently. Last week, I think, they just found a new prime number. Composite numbers. What's special about them? What are they? Anyone remember?
They have more than 2 factors.
They have more than 2 factors. That's very simple. Having issues. And order of operations. What's the order of operations? Who remembers back? It's like year 7, term 1. What do we do? Bid maths, is that what it's called? What do they stand for? B is for? Brackets. I is for? Indices. What's indices a fancy word for? That's a fancy word for powers. What's D? Division. M is multiplication. A is addition. And S is subtraction. That's it. That's really all our basic skills with numbers. Okay, we know what they are, we know their factors, we know multiples, we can operate with them, watch out for the negatives. That's it. Okay? Your turn to start the exercise. We can do exercise 1A. You can do all the questions as fast as you can with no calculator. And see how we go. Could you stop the video, please?